series, and in this Fourier series we have defined what is the Fourier series with the help of Euler formula. And in the Euler formula we are having Euler constants a0, an, bn, and we have done in previous classes to find out the Fourier series of a function which is a periodic with a period 2 pi. We have also done the question related to half range of the function. Half range means when in which the period is pi. We have also done the questions related to change of interval in which the period becomes 2L in place of 2 pi. We have also done questions related to the discontinuity of a function in which the function is discontinuous. Discontinuous means there is a break in the curve. Now, let us continue. This will conclude our topic of a Fourier series. In this topic, we have left with us some standard waveforms, and we have to compute the Fourier series. The first waveform is square waveform, that is square waveform, and the function is square waveform is the extension of the function f of x in which the value is minus a and e, and minus a is the value for the interval minus pi to 0, and a is the value in the interval 0 to pi. So this is the standard function, square waveform. You have to remember this function, the statement of this function. And obviously it is a periodic function because the period is 2 pi. Just see, the upper most limit is pi here, and the lower most limit is minus pi. If we subtract minus pi from pi, you will get the complete period 2 pi. Now, we can also revise the definition of a periodicity or period of a function. If f of x plus 2 pi is the same as fx, then the function is a periodic function with the period 2 pi. This is the definition of the periodic function. And the graph, because this is a square waveform, let us plot a small graph of this function. Here we have x-axis and we have y-axis, that is vertical axis and that is horizontal axis. And if we have minus pi, and then what does it mean? This is the value minus pi, and this is the value pi. And similarly, we can plot 2 pi and 3 pi and 4 pi and 5 pi, and we can plot. You just see the value in the interval. Obviously, this is the 0 point, and in the interval minus pi to 0, the value is a negative of a. It means the plot of this interval minus pi to 0, this one, this will be below horizontal axis, and for the interval 0 to pi, the plot of the function will be like this, above horizontal axis, because it is on positive side, the value is positive. And similarly, from pi to 2 pi, the value of the function will again come downward below horizontal axis, like this. And similarly for 2 pi to 3 pi, the function will be like this, and further the function will be like this. Now this is the rough sketch of the square waveform function. So this is a square waveform function drawn in the xy plane. So you must know what is the square waveform and how to plot its graph. Let us find out the Fourier series in the next page. Come to the next page. How to find out the Fourier series of the square waveform function. Now it is clear that the function is symmetric. Just see, the function is symmetric about the origin. because the shape of the figure below the horizontal axis is somewhat same or similar to the shape of the square piece above horizontal axis. So it is a symmetric about the origin. One more thing, it is an odd function because in the interval the value is a negative of that, and in the interval 0 to pi it is a positive of that. So if the function is an odd function, yeah, as we know, we have defined the Fourier series will be fx bn, and that will be sine nx. Now this will be sine nx, and n is clearly 1 to infinity. Now you just want to find out the value of bn. That is clearly 1 upon pi. The interval in this case is minus pi to pi, and it is f of x into sine of nx dx. And you know that this is a f of x odd function. Sine is already odd. Odd into odd is even function. So we can use the rule of plus 2 cos, as we have discussed in our previous class, that becomes 0 to pi and twice of that. That is f of x into sine of nx dx. First function becomes even function, and you know that in the interval 0 to pi, the value of f of x is a sine nx dx. You can simply integrate it to a upon pi. The integration is minus cos of nx over n. The interval is 0 to pi minus 2a upon pi. For the upper limit, when you put x as pi, you get cos n pi. The value of cos n pi is minus 1 raised to power n, and for cos 0, it come out to be 1, because cos 0 is 1. And here in the denominator there is n, so write on this n here. Now this is the value of the Euler constant Pn, this one. The negative sign can be adjusted over here to a upon n pi, that is uh, uh, 1, 1 can be written first, and minus 1 per n. Now you can find out the Fourier series by substituting the value over here. The value of Bn is 2a upon n by 1 minus 1 raised to power n into sine of nx. N is 1 to infinity. You have substituted the value, you can find out or take a constant of output. That is the 2a upon pi. Now, you can put n is equal to 1. When you put n is equal to 1 here, you will get minus 1 raised to power 1 is negative 1, and negative become positive. So 1 plus 1 become 2, and that is the sign. When you put n is equal to 1, you will get 2 sine x upon 1. Similarly, for n is equal to 2, what you get, minus 1 square is plus 1. 1 minus 1 will become 0. So there is no need to write down the value for n is equal to 2. And similarly, for n is equal to 3, you will get 2 times sine 3x over 3. Similarly, it means you are getting the value for odd natural numbers, and for even natural number, the value is becoming 0. 2 sine 5x upon 5, and so on. Now, 2 is common in all the terms, so 2 can be taken out. 4a upon pi. This is the value of f of x. This should be sine x over 1. This should be sine 3x over 3, and sine 5x over 5, so on. So this is your required Fourier series of the square wave function. So you must know how to find out the Fourier series of the square wave function. Now the next one is, we have sawtooth waveform. The next standard Waveform is waveform. We must know the definition of this function. The definition is f of x is x in the interval minus pi to pi. This is the definition of this function. Sawtooth waveform. Now, it is clear that a function is a discontinuous, and the graph of the function can be shown like this. You see, this is the horizontal axis, and this is the vertical axis. This is the origin point, and the value of the function for minus pi to pi. Minus pi to pi, this point is taken as minus pi, this one, this is minus 2 pi, and this is minus 3 pi, and be taken as minus 3 pi. Now on the right hand side of the origin, there should be pi, there should be 2 pi, there should be 3 pi, there should be 4 pi, and so on. You can take the values. Now, what does it mean? For the interval minus pi to pi, this term can be written like this, and this the graph of the function. I am plotting a rough sketch, so you can understand that. Sorry. Like this. So this is the straight line. Pen is not working in the graph properly, so you can admit that this is a straight line. Like this. This is a straight line. Now the point comes downward. This one at pi. Now again from pi to 3 pi, this becomes a straight line like this, and this should be here. Now, draw like this, and similarly at 3 pi, it comes downward up to the point, and same thing can be done at 4 pi. 4 pi. This is the sharp waveform. Okay, and you can also plot it on left hand side also. So this is like this, like this. You can join here. So the graph will be graph of a sawtooth waveform will be like this. Now you can find out clearly it is an odd function because the value is in the interval minus pi to become pi. And what does it mean? The value of the function come out to be on the other side of that. It will be on the negative side of the interval. The value of the function cannot be same as x. So this is an odd function, and it means we have to find out the Fourier series of an odd function. So the Fourier series again will be Pn sine nx, and you can compute the value of Pn. Again, it comes twice of that 0 to pi. What is the value of fx? Fx come out to be x sine nx dx. This is a little bit similar to the previous waveform, that is the square waveform. You can easily compute that the integration come out to be 2 upon n negative minus 1 bar n. You can complete it, and you can find out the Fourier series, that is minus 2 upon n minus 1 bar n sine nx. Now you can expand this summation and write down the Fourier series of the sawtooth waveform. you can clearly see that the value of the Fourier series comes out to be some standard terms. I mean, you can easily standardize or you can easily make generalization of this Fourier series. You can take a constant term out and put the values of n and write on the Fourier series. And after making a small adjustment, standard reduction will be like this: 2 sine x over 1, sine 2x over 2, sine 3x over 3, and so on. This is the Fourier series standard. So you can easily find out. Let us proceed further. We have a modified sawtooth waveform. The next page we have modified sawtooth waveform. So you can sawtooth waveform. This is the name of the waveform. You can define the function. The function is like this. This is a little bit different than sawtooth waveform because this is the modified form. The value becomes 0 in the interval minus pi to 0, and the value becomes x in the interval 0 to pi. So it is function is a periodic with a period 2 pi because uppermost limit is pi and the lowermost limit is negative pi. It means it is a periodic function. So x plus 2 pi is same as f of x. Now, the plot of the function, this function will be on horizontal axis, and this is the y-axis. This is the origin point, and in the interval 0 to pi, this is the 0 to pi, pi to 2 pi, this is the 3 pi, and this is the 4 pi, so on. Similarly, on the left hand side, this is the minus pi. It is 0 to pi, the value of the function come out to be positive value on the positive side. So it can be said that the graph, modified sawtooth waveform will be like this one, and this is the pi point. And what does it mean? This is y is equal to pi. So you can plot a line like this parallel to the horizontal axis, and we can say that this is y equal to pi. And what about this? Other side, from pi to 2 pi, this becomes 0. So this is the value. And for 2 pi to 3 pi, there should be the value. The graph will be like this. You can join at pi, 5, and so on. Similarly, on the left hand side, you can also write like this. This is the value 0 in the interval minus pi to 0, but from the interval 0 to pi. What does it mean? At this point, the value of x is pi. Value of y is pi, because this is the horizontal point we have, and this is also the vertical point. So x equal to pi and y equal to pi. And also draw a line at y equal to pi. So this is also pi, and you can move like this. Arrows are showing that the graph is moving in this interval, but for pi to 2 pi, the value becomes 0. But 2 pi to 3 pi, the value becomes x. So it will be like this. Mean 0 to pi, the value is moving upward x. X mean at x equal to pi. We are taking a particular value for making it a periodic with period 2 pi. And for pi to 2 pi, it becomes again 0. But 2 pi to 3 pi, the value becomes x. So this is the meaning of a modified sawtooth waveform. Now I leave it as a assignment to you to complete it and find out the Fourier series. The method is the same, and make sure, because this is a complete function with a period 2 pi, so there is no case of even odd function. You have to solve the question and finding out all the Euler constants. And the Euler constants are a equal a n b, and write down the complete Fourier series. Similarly, we have another waveform, that is the triangular waveform. Triangular waveform. And for the triangular waveform, the function is the standard function, that is 1 plus 2x upon pi, and the function is 1 minus 2x upon pi. And the interval is minus pi to 0 and for 0 to pi. This is the value. The graph of the of this waveform of this extension is, again will take horizontal axis, x-axis and y-axis. You must remember the definition of the waveform. Sorry. And also the plot, and together with it's a Fourier series. Now let us divide it. This is the point minus pi by 2, and this is the point on the right hand side. This is a positive pi by 2, and this come out to be complete pi, and this come out to be 3 pi by 2. Because it is a triangular waveform, the we can plot like this, and the point is passing through this point, this one, into the point pi by 2, and the graph is like this. We can take this as 3 pi by 2, and similarly we can plot like this. That is why this is a triangular waveform, because the shape of the graph come out to be a triangle form like this. This is the point pi by 2, and this will be the point negative of pi other side. This is negative pi, and this is positive. Because this is a rough and sketch, I think the lines are not so straight, but here these are straight lines. So this is the shape of the triangular waveform, and you have to find out its Fourier series by computing the values of Euler constants a0, an, and b. This is clearly an odd function again. No, this is not an odd function. You have to find out the values of the constants. So we have this is the topic. One more thing, we have a half wave rectifier. Half wave rectifier. Half wave rectifier, the function is f of x is I naught sine of x, and this is 0. The value is 0, and this is for the interval 0 to pi, and this is for the interval pi to 2 pi. So it is also a periodic function. This is the half wave rectifier form with the maximum current I naught, and the shape of the figure. You must remember the definition. The shape of the figure is like this. And this is the interval 0 to pi, and this is the pi to 2 pi, and 2 pi to 3 pi, and like this is the horizontal axis, x-axis, and this is the vertical axis. Okay. So touching the topmost corner of the shape, you need to plot a straight line. This is touching at the point. This is a tangent, not a secant. Please rectify it. This is a tangent, not a secant. Like this. So this is the waveform. Another waveform, half wave rectifier. You can also find out its Fourier series by computing the values of either constants a0, a, and e, like the results as we have done in the previous topic of Fourier series. Now, in the full wave rectifier, the complete function is, I am also writing down here, that is full wave rectifier, and the value of the function comes out to be, that is a naught sine of x in the interval 0 to pi only. This is straight away the function full wave rectifier, and the graph of the function is like this. Full wave become, there is there is also a curve like this from pi to 2 pi complete, and similarly on the left hand side also, this is pi, this should be minus pi, and then the curve is like this. We can say that this is joint, and what does it mean? It means there is no gap from 0 to pi, the curve is like this, and again for pi to 2 pi, the curve is like this. As a curvy linear curve, we are getting, but in half wave rectifier, there is a gap. For 0 to pi, there is a curve, but for pi to 2 pi, the value becomes 0. You just see. But it is for 0 to pi, the value is same. For pi to 2 pi, the value is like this. For 2 pi to 3 pi, the value is like this. So this is the definition of a full wave rectifier. So you must remember these standard statements of a full wave rectifier and a half wave rectifier along with other previous terms. We have uh, uh, we have started with the square waveform. This is a square waveform, and we have written this function and find out this is the shape of the square waveform, and we have computed the Fourier series here, just parallel to the topic of the Fourier series. And using the concept of Fourier series, then we have a sawtooth waveform, and this is the sawtooth waveform, and then the Fourier series is computed like this. This one, easy to compute a Bn. There is no problem. There is a standard basic integration you have to do and find out the value of En. And similarly, we have modified sawtooth waveform. This is the shape of the curve, and we can find out its Fourier series also by finding out the constant. Similarly, we have triangular waveform, and the shape is like this, and you can find out the Fourier series. This is the full wave, half wave rectifier, and this is the full wave rectifier. On the same pattern, you can find out their Fourier series also. You must be well versed with the basic definitions of these standard waveforms, and you must be aware how to find out the Fourier series of these standard waveforms by finding out the Euler constants. Okay, so you must. I think it is sufficient to have knowledge about these standard waveforms. So the terms which the Fourier series have, I have not found out, I have not completed the Fourier series of all the waveforms, so you need to complete it at your home as a home task, because this will be a very good practice for you. So you complete it, the Fourier series of the remaining waveform which I will give. Thank you very much. Thank you.